Arriving at Saturn on the 30th of June 2004 and ending in a blaze of triumphant destruction on the 15th of September 2017, the Cassini-Huygens probe travelled 4.9 billion miles, took an incredible 453,048 images, whilst collecting 653 gigabytes of scientific data during its mission. But what did we learn from this mission, and why did it end in such dramatic fashion? Let's find out. Peering back 890 million miles is Cassini, which captured this image of a distant Earth and the Moon. It also captured this image of Saturn, Saturn's rings, and Earth just off to the right. Both of these incredible images had their origins in a journey that started 4,000 years earlier, when the Babylonians were peering the other way. They observed the paths of 5 bright objects travelling across the night sky. These 5 objects, in relation to other stars, were behaving differently. This fired their imagination and sense of wonder as to what they were and what it meant. Ever present in the centuries and the millennia that followed, these 5 objects have helped shape our understanding of the solar system and our place within it. The heliocentric model with these 5 wandering stars and Earth revolving around the Sun was first proposed by the ancient Greeks, whilst the Romans left their own footprint on planetary history by naming these wandering stars after some of their gods, one of which was their god of agriculture, Saturn. For most of those 4,000 years we could only look up to Saturn with the unaided eye, but as our technology improved, so has our understanding, culminating in ever more ambitious space exploration programs that peel back Saturn's secrets that bit further and provide us with a rich tapestry of data and imagery. Then in 1997, with the launch of the Cassini-Huygens probe, we could look at Saturn in unprecedented detail for what turned out to be a 13-year mission. Saturn is often described as the jewel in the solar system, and it's not hard to understand why when you gaze upon the vastness and beauty of Saturn and its rings. But when in 1610 Galileo Galilei focused on Saturn with a handmade telescope, all he could describe was Saturn having 2 bodies either side of it, hardly a description of beauty. But then in 1655, with better and more powerful telescopes, Cassini-Huygens determined that Saturn had a solid ring structure around it. Shortly following, in 1676, with Giovanni Cassini discovering the rings weren't solid but had gaps in them, and with it Saturn's beauty was slowly being revealed. Saturn's journey to prominence in the solar system began some 4.5 billion years ago. Its formation is thought to have started 3 million years after the formation of the first planet, Jupiter. By this time, Jupiter had consumed vast quantities of material when it formed, leaving less available when the pull of gravity upon dust and gases coalesced to form Saturn. Saturn, with less building blocks available at the outset, would become the 2nd largest planet and 2nd oldest planet in the solar system. Even so, with an equatorial radius of 36,184 miles, 9.5 times more than Earth, volumetrically 764 Earths could fit inside Saturn, so it is still pretty big. As a gas giant, Saturn does not have a surface and primarily consists of approximately 75% hydrogen, 25% helium, with trace elements of ammonia, water crystals and hydrocarbons like methane. Its surface is categorized by clouds, with an upper atmosphere separated into bands that are predominantly yellow or orange in colour. The upper atmosphere is particularly extreme, where wind speeds can reach a staggering 1,800 km per hour, with storms lasting for months. These are partly caused by Saturn's high rotational velocity, which at 35,500 km per hour, or 22,058 miles per hour, is 22 times quicker than the rotational velocity of Earth. Wind speeds at the North Pole are also extreme and can reach up to 500 km per hour, where it is thought jet streams from deep within the planet help create incredible hexagonal shapes at the North Pole. Each side is roughly 14,500 km, wider than Earth's diameter, with the whole hexagonal being 29,000 km across and 300 km deep. In common with Earth, Saturn produces auroras at both poles, But in Saturn's case, these auroras produce enough energy to heat the planet's upper atmospheric layers. This discovery, made by Cassini, helped resolve the mystery as to why Saturn's temperature is far higher than you would expect for a planet so far away from the Sun. The Cassini mission may have helped in our understanding of the rings, but even with the knowledge we now possess, scientists are still not sure how they were formed. One theory is that they are a result of high gravitational forces Saturn exerts on moons, asteroids and comets, which then fracture into smaller fragments. This body of material, consisting of ice and rock, is in constant motion. Over time, one fragment will collide with another, fragmenting further into ever smaller pieces, resulting in the rings we see today. This process repeats and has been going on for millions of years, with fragments now ranging in size from a grain of sand to pieces several meters across, forming a ring system that has a thickness of 1 kilometer and about 175,000 miles or 282,000 kilometers across. This vast mosaic structure is made up of 7 rings, with 4 main rings and 3 fainter, narrower rings. Gaps exist between them, with some being caused by moons travelling within the ring structure itself. The rings are relatively young when compared to the age of the planet, where it is estimated they formed 100 million years ago, sometime during the age of the dinosaurs. However, we may not know how they were formed, but we do know they will disappear one day, because Saturn is devouring them at an astonishing rate of 10,000 kilograms per second, with material falling towards Saturn due to 2 mechanisms. The electrically charged ionosphere is interacting with ions that were created when ultraviolet light hits the water ice rings, funneling them down to the southern and northern latitudes, whilst ring material is often falling to the equatorial region. Cassini has played its part in helping us piece this together, and we now estimate that the rings will be gone in about 100 million years. This last discovery was made during Cassini's final mission, when 20 years after launch and 13 years around Saturn, Cassini was sent on an ever closer orbit by diving through the 1,500-mile gap between planet and the innermost ring. No space probe had ever done this before, and during 22 orbital dives, travelling at 77,000 miles an hour, it went through this gap with the sole purpose of capturing precious images and data. On its 22nd and final descent, its real-time data link was initiated, and at 1,200 miles from Saturn, its attitude control thrusters fired to ensure the space antenna pointed at Earth. As it got closer to the planet, the thrusters increased, maintaining stability, while the last pieces of precious data were being sent back to Earth. With attitude thrusters maxed out, and at 930 miles above the clouds, the inevitable happened and Cassini started to spin and lost control in a backward tumble. Contact with Earth was lost, with Cassini streaking across Saturn, burning up in the upper atmosphere. But before it had lost contact, it sent back one last image of Saturn, an image of one of the 5 wandering stars we first thought were special some 4,000 years earlier. Saturn hasn't disappointed, and neither has Cassini.